Okay, so you need help on your complex numbers homework. So I have it here. I'll probably go ahead and do a little bit of this, help you out with it. I don't know how much of it I'll do, but I will try to keep it short. All right, so let's go ahead and jump into this. Number one, the square root of negative 36. Now, the issue that we have with these problems is we're not supposed to be able to take the square root of negative numbers. If I try to type that in my calculator, I would get an error because it's technically not possible. But we're going to work with something called imaginary numbers here. That's the idea of complex numbers, is it's based off the premise of an imaginary number. And the imaginary number that we're going to use is I, and that's going to be the square root of negative 1. So again, we can't physically take the square root of negative numbers, but what we're going to do is basically call our negative a negative 1, and then call that imaginary, and then pretend like it actually exists. So, with the square root of negative 36, the first thing I want to do is separate the negative from the 36. So I'll do that by separating this into negative 1 and then a positive 36. So what I've done is I've split this up. I've separated the negative away from my 36. Because I know what the square root of 36 is, and I can simplify that because now it's positive. That's a regular old-fashioned 6, right? Square root of 36 is 6. Now, the square root of negative 1, again, this is what we're going to call I. So anytime I see that square root of negative 1 or have that square root of negative, we're going to be calling it I. So this, I'm just going to call that I. Making my answer I6, or a better way of putting it would be 6I. In number 2, we're going to do the same thing. I have a 2 that's outside the radical, but let's not worry about that yet. Let's worry about just simplifying the square root itself. So just like the square root of negative 36, what I want to do is separate my negative here from the 49. Okay? So what I've done, again, is I had negative 49, but I've separated the negative to make my 49 positive now. The square root of 49 is 7, right? It's a perfect square. And like I said, the square root of negative 1 is going to be called I. So this is going to give me 7I. However, don't forget I had 2 in front, right? So that's 2 times this now 7I, which in the very end will of course make this 14I, because I can multiply the 2 with 7. Alright, and number 3 is the same idea. We have the negative 3 on the outside, which again, we will use that at the very end of the problem, just like we used 2 in the last problem. We'll multiply it at the end. But now let's again focus our attention on separating my negative from my 18. Okay? So again, that square root of negative 1 is something we're going to call I. Now I have to simplify the square root of 18. Notice 18 is not a perfect square. So you have to try to figure out what perfect square goes into it. We did this in the radicals review, but your perfect squares, if you don't remember, are 4, 9, 16, 25, 36, 49, 64, etc. And why are these perfect squares? Well, 4 is a perfect square because it's 2 times 2. 9 is a perfect square because it's 3 times 3. 16 is 4 times 4. 25 is 5 times 5. And so on down the list. 18 is clearly not among that list. It is not a perfect square. It would give me a decimal if I tried to take the square root of it. But to simplify, I will try to find which one of these perfect squares divides into 18. Right? And I can take 18 and try to divide it out and see what would work. So I realized that I could use 9. 9 is a perfect square that goes into 18. 9 times 2, to be more specific, makes 18. And I can simplify this. I'm going to bring my I down. I'm not going to change that. But the square root of 9 is 3. It's a perfect square. And the square root of 2 is my remainder, and it stays the same. I'm not going to change that. So this becomes a 3I square root of 2. But again, don't forget, I have that negative 3 in the front, so I have to multiply my negative 3 with that, making it a negative 9I square root of 2. Because negative 3 times 3 is a negative 9. Now, for number 4 and 5, we have an equation, and we're just going to solve this equation. So the idea is to get the x by itself. Okay? And basically, it's like solving any other equation, but your goal is to get everything out of the way until you have x squared by itself, and then we'll square root it, because the opposite of squaring something is to square root something. So by square rooting at the end, I'll be able to cancel out the squaring and just have the x by itself. So let's begin this process. Just like any equation, I would start by subtracting my 81 here. And that would leave me with 3x squared equal to negative 81. I would divide by 3, because again, I'm going to worry about that exponent at the very end. Dividing by 3, that'll leave me with x squared equal to negative 27. Right? Negative 81 divided by 3 is negative 27. And now the opposite of squaring something is the square root. So at this stage, I'll square root both sides so that I can cancel that square out and leave just x. But now I've got, one of these to simplify. So just like previous problems, separate your negative from your number, right? The negative from the 27, and then simplify those parts. So square root of negative 1, again, just like always, we're going to call that I. And the square root of 27, just like the 18, I think, in the previous problem, is not a perfect square, so you try to break it up. So you can find that 9 is a perfect square that goes into 27, 9 times 3 more specifically, making this problem I, 3, square root of 3. The square root of 9 is 3, so that's where I get that from. So my answer at the end is 3i square root of 3. Now it's technically positive negative 3i square root of 3, but we can say that for another time. So number 5 is very similar to this process. Go ahead and try that one out. So number 6 and 7 are also identical to each other, so I'm just going to do number 6, and I'll let you do number 7. And I think one of these is a fraction. I don't know which one comes out as a fraction. I think you get a fraction for the answers in number 7, but it's okay. Don't worry about that. It's the same process. So these are two complex numbers. A complex number is a number that looks like a plus bi. Okay? So, for example, a complex number could be 3 plus 4i. That's a complex number. It's got a real part and an imaginary part. You can tell the difference because the real part is a regular number. The imaginary part has a bloody I on it. So you can't really mix them up. But, so the idea of this is, what if I told you that 6 plus, I'm just making one up here, 6 plus 7i equals 6 plus 7i. Right? Two complex numbers that are equal to each other. Would you believe me that 6 plus 7i equals 6 plus 7i? Well, you should, because they're exactly the same, so why wouldn't they equal each other? That's the idea of what you're doing here in number 6 and 7. These are equal to each other because the 6 is the same as the 6, and then the 7 is the same as the 7. Okay? So I've got here 2x and 8, and, well, 2x needs to be an 8, well then what is x, right? You're not trying to solve anything, you just got to figure out what x is. If this term is supposed to be 8, right, then what does x need to be? Well, x would have to be 4, because 2 times 4 is how you're going to get to equal 8. And you do the same thing for the 20 and the 4y. Don't worry about the i's. This is a 20, so this needs to be a 20, right? 4 times something needs to be this 20. And that something is going to be 5. Y would equal 5. So the idea essentially, if you don't like thinking of it like that, is you just take the real parts and you have them equal each other. For instance, 2x is supposed to be equal to 8, and the negative 20, because it is a minus sign, is supposed to be equal to a negative 4y. And the idea here is you can just solve those two equations, right? If you did it the old-fashioned way, you can do it like that, and you still get the same result. Right? But you can do one or the other. My way of thinking about it is just, 2 times something equals 8, so what is that something? That's sort of how I think about it. You're probably going to be better off making these two equations, though, for number 7, because I do think you get fractions there as your answers. So setting up your two equations like this is probably a little bit better. And just to get you started, for instance, the 5i and the 10y. Don't worry about the I, but the 5 is supposed to be equal to 10y, and the negative 6 is supposed to be equal, the negative 6x is supposed to be equal to 2. Right? So those are your equations that you can solve and put together. For number 8, 9, and 10, the conjugate just means opposite. So you have to be careful, but the idea is First and foremost, your complex numbers are supposed to be written as a plus bi. The real part first, the imaginary part second. So what I encourage you to do is go ahead and write all of these in that format first. So notice in number 8, this is not set up correctly because the I is the first term. So I'm going to go ahead and just switch these right now. So this is really supposed to be a negative 3 plus I. Okay? When I say switch, I don't mean just switch the numbers around. I mean like switch the terms. So that's a positive I, right? So it should still be a positive I. And the negative 3 is a negative 3, so it should still be a negative 3. Don't just, if you just write 3 minus I, you're not actually switching them because you're changing this 3 to a positive 3, and you're changing that I to a negative I, which is not the idea that we're trying to do right now, okay? Just switch the terms, okay, but keep those signs the same. So I have a negative 3, and I have a positive I. But it's written like this, right? The real part first, the imaginary part second. I'll come back and do the conjugate of that in a moment, but let me go ahead and do number 9. If I want to switch number 9, again, I have the imaginary part first. I really need to be written second. So this should be written as negative 4 plus 3i, right? Because 4 is a negative number, 3i is a positive number, so that's how it should be written. Once it's written like that, the conjugate's really easy, because all you have to do is change the sign in front of your I term. So the conjugate for number 8 is negative 3 minus I. Alright? That's it. You just change the sign for the I, that's your conjugate. But it's easier when you have it set up properly. So that's why I took them a minute to set these up properly. So the conjugate of number 9 is negative 4 minus 3i. You're not changing the sign for the real part, right? The negative 4 is still a negative 4. You're only changing the sign for the I part. Okay? I'll let you do number 10. Alright, number 11 is a quadratic. Use your quadratic formula to solve this. Okay, your quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. Now here you have 2 as your a, negative 12 as your b, and then 40 as your c. So plug those numbers in, work your formula out, and see what you get as a result. Alright, that's going to cover it for this video, guys. I hope it helps a little bit in that homework. I'm going to move on and see you in another one, hopefully. Alright, sayonara.